At 0700 hours on May 31, 2024, the radar operators inside Russia's most advanced S-400 air defense battery were fighting the kind of boredom that usually precedes a catastrophe. Stationed near Anapa on the Black Sea coast, they were guarding a critical gas terminal that fuels the Russian war machine in the south. On their screens, the morning air traffic looked perfectly routine, but what they could not see was that 3 distinct radar contacts had just dropped below the horizon line, effectively vanishing from the electromagnetic spectrum. In exactly 3 minutes, this quiet morning shift would turn into a masterclass on why billion-dollar air defense systems are sometimes helpless against high school-level physics. 3 Ukrainian FP-5 Flamingo light aircraft, converted into crude cruise missiles, were skimming the wavetops at 200 feet. Their composite fuselages, made of E-glass fiberglass woven into epoxy resin, were cutting through the salt air at 540 miles per hour. Each missile weighed 1,300 pounds. Thanks to that composite skin, they registered on radar with the cross-section of a large seagull. The Russian operators were about to learn a very expensive lesson in geometry, because the detection problem here wasn't about technology. It was about the curvature of the Earth. At 200 feet above the water, based radar simply cannot see past 22 miles. It does not matter if your radar costs $500 million. It cannot look through the ocean. The flamingos were surfing inside this blind spot, completely invisible, racing toward a target that was entirely unprepared for what was coming. The Russian 91/6E Big Bird acquisition radar finally swept the southern horizon and picked up a flicker of a signal that made no sense to the automated tracking software. The phased array antenna, designed to track 300 targets simultaneously out to 370 miles, was struggling to resolve these ghosts. The contacts would appear for 2 sweeps, vanish for 3, and reappear on a slightly different bearing, creating a nightmare for the fire control algorithms. The operator saw velocity data that proved something was moving at 500 miles per hour, but the return signature was so faint it looked like sea clutter or atmospheric noise. This was the genius of the Flamingo's design. It wasn't a stealth fighter, it was just plastic and foam. The airframe breaks down into 3 simple sections. The forward section houses a guidance package that would make a commercial pilot jealous, and an inertial measurement unit containing 3 ring laser gyroscopes and 3 accelerometers, paired with a GPS receiver equipped with specific anti-jamming filters. But the real weapon was the material science. The fuselage's honeycomb core provided structural integrity without the radar-reflecting properties of aluminum. By the time the Big Bird radar finally achieved a stable classification at 073 hours, the Flamingos had crossed the 22-mile detection threshold. The system screamed a warning. Velocity 541 miles per hour, altitude 190 feet, heading 047 degrees magnetic. Profile match, cruise missile. The S-300 battery next door woke up 8 seconds later, confirming the track. But by then, the engagement window had already collapsed from minutes to seconds. The battery commander at the S-400 site stared at a screen that was quickly filling with bad news. He had maybe 50 seconds before the first missiles impacted the gas terminal, now just 18 miles behind him. The 92 N6E Gravestone fire control radar slewed its massive antenna toward the contact, its narrower beam burning through the electronic noise to build a precision track for interception. But as the radar locked on, the picture got worse. Behind the first Flamingo, 2 more contacts resolved into hostile tracks, and behind those, something else was emerging from the sea clutter. Slower, more numerous, and flying in a swarm formation that the system couldn't count fast enough. He didn't wait for coordination. He ordered the engagement. The launch sequence took exactly 4 seconds from the command to ignition. The gas generator inside the launch tube pressurized the ejection system, and compressed nitrogen kicked the 48 N6DM interceptor clear of the vehicle at roughly 100 feet per second. This cold launch technique protects the expensive radar vehicle from the rocket's exhaust. The solid fuel booster ignited only when the missile was safely airborne, accelerating the 4,000-pound interceptor to hypersonic speeds in the blink of an eye. The 48 N6DM is a terrifying piece of engineering. A 2-stage interceptor nearly 23 feet long and capable of pulling 20 G-turns. But today, it was being asked to hit a target flying so low that the radar returns were mixing with the waves. The lead interceptor's proximity fuse triggered 40 feet from the first Flamingo. Close enough. The warhead's tungsten fragments shredded the drone's tail section, severing hydraulic lines and sending the cheap composite airframe tumbling into the Black Sea. 1 threat down. But the second interceptor lost its lock at the worst possible moment. The Flamingo jinked, or maybe the radar just lost it in the wave trough, and the Russian missile's onboard logic sent it into self-destruct mode rather than risk hitting friendly territory. One Flamingo down, two still inbound, and their fiberglass skins were soaking up radar energy like sponges. The gas terminal was now 14 miles away, less than 90 seconds of flight time. The S-300 battery requested a handoff on the trailing contacts, but handoff requires the 55 K6E command post to reconcile track numbers between batteries, a process that takes precious seconds. The data link was still negotiating protocols when the second Flamingo crossed the 20-mile threshold. Panic set in. 4 more missiles launched in rapid succession. 2 from the S-400, 2 from the S-300. For 6 seconds, both batteries were engaging the same target, wasting millions of dollars of ordnance on a single drone. The S-400's interceptors arrived first. One scored a proximity hit that gouged the Flamingo's wing root. The other missed cleanly. The S-300's missiles found only a debris field where the cruise missile used to be. 2 Flamingos down, $8.4 million in interceptors expended. And the third Flamingo was already past the engagement zone, descending toward the coast at 540 miles per hour with its 2,500-pound warhead intact. But the real nightmare was just starting to appear on the scopes. The Flamingos were just the opening act, a noisy, fast distraction designed to force the Russians to reveal their radar positions and waste their ready-to-fire missile. The contacts that actually mattered were 2 tracks now designated Hostile 07 and Hostile 08. These weren't converted light aircraft. These were the signatures the operators had trained to fear since April 2022, the same weapons that sank the Moskva. These were the long Neptune missiles, and they exist because Ukrainian engineers asked a very simple question. What happens if we make the fuel tank bigger? The extra space in the 20-foot fuselage isn't for a larger warhead. It is almost entirely for jet fuel. The MS-400 turbofan engine, producing roughly 900 pounds of thrust, now had enough propellant to push the missile 620 miles instead of 175. The warhead did grow to 570 pounds, but the real innovation was in the guidance. The original Neptune used active radar homing, which is great until the enemy detects your radar emissions of solid. The long Neptune deleted the radar seeker entirely. In its place, it uses a guidance computer running 3 navigation modes simultaneously: primary GPS, secondary inertial navigation using ring laser gyroscopes, and terrain reference navigation. It doesn't look for the target. It simply knows where the target is based on math and coordinates. The S-300 battery commander recognized the Neptune signature instantly. His operators pushed the classification up the chain, but the command post was still trying to untangle the mess from the Flamingo engagement. The Neptunes had crossed the coast near Vasilovka, 40 miles southwest of the gas terminal, inbound at 560 miles per hour. Behind them, 14 drone contacts were crawling across the scope at 120 miles per hour. The S-400 had only 6 missiles remaining in its ready tubes. The S-300 had 8. That is 14 interceptors against 16 confirmed threats. The math was brutal. The Neptunes were the only targets that could inflict catastrophic damage in the next 90 seconds, so the battery commanders made the only choice they could: ignore the drones and kill the missiles. Their interceptors rippled off the rails within 4 seconds of each other. Hostile 07 took 3 hits and disintegrated over the coastline, a fireball of burning jet fuel and electronics. But Hostile 08 was luckier. As the interceptors closed in, the Neptune banked hard, dropping behind a low ridge near Golubitskaya at exactly the wrong moment for the Russian radar. The 48 NA6DM lost its lock. One detonated 50 feet away, close enough to pepper the missile's skin with shrapnel, but not close enough to kill it. The Neptune emerged from behind the ridge trailing debris, its control surfaces chewed up, but its computer was still alive. While the strategic air defense systems were busy fighting the cruise missiles, the Buck M3 battery positioned 15 miles east of the gas terminal was facing a completely different problem. The operator watched 14 contacts inbound from the southwest, velocity reading 130 miles per hour. These were obviously propeller-driven drones, probable type, one-way attack. The Buck M3 is optimized for hitting aircraft and cruise missiles, not slow-moving plastic toys. Its 9S-36 engagement radar painted the lead contacts, identifying them as the Ukrainian Ludi drone. The Ludi is nothing special to look at, a tube-launched fuselage about 12 feet long with a 22-foot wingspan, carrying 75 pounds of explosives. But inside that cheap airframe is a guidance system called Skynode S that is terrifyingly smart. It contains a multi-core processor, an inertial measurement unit, and a downward-facing camera. 10 times per second, that camera captures a frame of the terrain below, roads, rivers, buildings, and compares it to a reference map loaded before launch. It is literally navigating by sight. Even if the Russians jammed every GPS signal in the hemisphere, the Ludi would still know exactly where it was by looking at the ground. The Buck commander had 36 missiles, but he couldn't reload in the field. He had to decide whether to spend a $300,000 missile on a $20,000 drone. 8 miles northeast of the gas terminal, the Russian Pol 21 jammer site was doing exactly what it was designed to do, screaming electromagnetic noise across the L-band and GPS frequencies. The Pol 21 is a distributed system, a network of small jamming nodes mounted on cell towers and utility poles that creates an 80-kilometer dead zone for satellite navigation. Against standard GPS-guided weapons, it is a force field. Against the Ludi drones, it was useless. As the drones entered the jamming bubble, their GPS receivers reported signal degradation. The Skynode processor noticed the error. Satellites claiming the drone had teleported 600 feet sideways instantly and simply stopped listening to the GPS. It switched priority to the visual navigation system. The camera saw a road intersection that matched the stored map coordinates, corrected the drift, and kept the drone on a rail. The Russian electronic warfare operators were pumping out megawatts of jamming energy, convinced they were blinding the enemy, while the Ukrainian drones were simply looking out the window and flying straight past them. It was a technological checkmate. You can jam a radio frequency, but you cannot jam a physical landmark unless you physically move the road. The Buck M3 commander, realizing the electronic warfare was failing, panicked. The surviving Neptune missile, Hostile 08, was still the highest value target, but the drones were getting uncomfortably close to the tanks. He fired two 9M317M interceptors at the damaged Neptune. The first missile arrived from above, its proximity fuse triggering at 30 feet. Tungsten fragments punched through the Neptune's tail section, finally severing the hydraulic lines. The cruise missile pitched down and slammed into the Black Sea 400 yards short of the beach. Its 570-pound warhead detonated on impact, shaking the ground but sparing the gas terminal. But that left the drones. The Buck battery began firing on the lead Ludi drones. This is where the physics of radar fuses becomes a nightmare. The missile's proximity fuse works by broadcasting a continuous radar wave and listening for the reflection. Against a fighter jet, the reflection is huge. Against a Ludi drone made of foam and fiberglass, the reflection is barely a whisper. 4 missiles launched, 2 hit, 2 missed, not because they didn't get close, but because the fuse didn't realize it was close enough to detonate. The battery had just burned $1.2 million to shoot down $40,000 worth of drones, and 12 of them were still flying. With the air defense magazines depleted and the electronic warfare rendered useless by optical navigation, the terminal phase began. The lead Ludi drones crossed the perimeter fence at 0712 hours. The Panzer S-1 air defense vehicle stationed near the tanks opened fire with 30mm cannons, desperate to stop the swarm. They managed to shred 4 drones in a hail of tracer fire, but the remaining 8 were now in their terminal dives. The first drone targeted Tank 7, a massive pressure vessel filled with 200 cubic meters of liquefied petroleum gas. The 75-pound shaped charge warhead struck center mass. It didn't just explode. It punched a hole through the half-inch steel shell and injected a jet of superheated plasma into the liquid gas. The tank didn't just catch fire, it suffered a BLEVE, a boiling liquid expanding vapor explosion. The sudden pressure drop caused the liquid gas to flash boil instantly, expanding 600 times its volume in a fraction of a second. The steel tank didn't rip, it vanished. A fireball rose 200 feet into the air, creating a shockwave that flattened the perimeter fence and knocked the Panzer crews off their feet. The destruction was not linear, it was exponential. The heat from Tank 7's explosion instantly heated the neighboring Tank 9. The safety valves on Tank 9 were designed to vent excess pressure, but they were never designed for a fire this intense. The valves melted or failed, and 15 seconds later, Tank 9 ruptured in a second catastrophic explosion. The burning fuel flooded the containment berms. The remaining Ukrainian drones didn't need to hit the tanks. The fire was doing the work for them. But they hit them anyway. One drone struck the transfer manifold, severing the connection between the rail yard and the storage farm. Another hit the loading rack. By 0720 hours, 22 of the 30 storage tanks were either destroyed or burning uncontrollably. The combined thermal output created a firestorm visible from satellites, a column of black smoke rising thousands of feet into the atmosphere. The Russian air defense network had successfully engaged the decoys and the cruise missiles, expending nearly $30 million in advanced interceptors, only to lose the entire facility to a swarm of slow, cheap drones that simply refused to get lost. The fire burned for 3 days, halting fuel logistics for the entire southern front.